warming, all right. Wherever you sit on this issue, on the side of science or ignorance, let's see what this says. Subjects were asked if there's solid evidence that the Earth is getting warmer. 20% said that there is no such evidence out of 1,501. Tests claim that less than 25% believe there is not solid evidence. Blah, blah, blah. So this is not a bad little review problem to do before we get into chapter 10. I'm not going to do more than one of these, to tell you honest, because they do take a little bit of time. I need to devote most of the day to chapter 10. I will go ahead and do this one. This is, again, hopefully I'm looking at the right one, right? 26, section 8.3. So where do I want to start with this? What's the very first thing you should locate?
The claim.
The claim, cool. And what's the claim being made?
Less than 0.25.
I like it. So the claim, what letter do I use?
P.
P is less than 0.25. So which one is that going to be, the HO or the H1?
The high.
The high, I like it. Cool. So that's going to be P less than 0.25, that's my claim. And what's the HO going to be then? Yeah, either you could say P equal to or P greater than or equal to. I lean in the direction of putting that, obviously, because that's what I put. But you'll see a lot of books say equal to is fine also. So that's fine if you want to put that. So how many tail tests would Liz be?
One.
One tail on which side?
Left side.
Up there, yeah. Greater, sorry. Less than. So that's going to be a one tail. That's a greater. Okay, cool. What's the next step? Step A, step B.
Find which is normal distribution.
Yeah, exactly. What am I allowed to use, right? So it kind of makes sense. Hopefully these steps make sense. And when I was taught it was 8 steps, I boil it down to the 5 essential steps. What the hell are you talking about? What are you going to use to talk about it? C and D are then do it, and then E is what the hell just happened, right? So B, what's my alpha? Oh, I'm sorry. What's my sample size?
15 and 1.
So what do I have to check? It's not just the fact that N is bigger than 30. What do I actually have to check?
NP and NQ.
Yeah, so NP, NQ, 1501. And what am I going to put in there for P and Q?
0.25.
Beautiful. You look back up to your claims. You use that number there. So quarter of 1500.
NQ, don't you put 0.75?
75, yeah, sorry. I'm almost here mentally this morning. So what do you get there?
375.25.
375.25. So this will be 1124.75.
25.75.
Okay. Oh yeah. Oh, 1. Cool. So am I allowed to use z-scores?
Yes.
If either one of these were less than, what's the critical number here?
5.
5. If either one of those is less than 5, what would I have to do then?
There's nothing you can do.
There's nothing you can do. There ain't shit you can do, right? Do you ever use t-scores with an NPQ problem? No. Either that it's normal, so I use z-scores, or it ain't normal and I can't do anything, right? Both z and t require normal, right? So if it's not normal, if it doesn't say it's normal and the sample size or these guys aren't right, you can't do anything. Not according to this class anyway. There is something you can do, but it's not very powerful, but that's for a later class. So these are both bigger than 5. So I can use z-scores. Check. Cool. Now that I know I can use z-scores, what can I set up for the next step?
Rejection region.
Rejection region. Cool. And on this problem, what's alpha? Careful, alpha, yeah. 0.01. And it's a one-tail test. And I can use z-scores. So what z-score is appropriate for that? situation.
2.326.
I like it. And since it's down here, what's got to be true about it?
It's negative.
Negative. So don't get overly dependent on charts. We are semi-dependent on charts in this class, I understand. But a lot of them just give us the pure number. We have to know when to put the negative on there or not.
So every time it goes to the left, it's a negative?
Yeah, because right in the middle is what?
0.
So he's got to be negative down there. Negative means below the mean. Below the middle. And I want to show that it's below this supposed number here. So that's why it's going to be a negative z-score. So in words, this would mean if z star is less than negative 2326. We can do what? Reject the hoe. Which also means we can support the high.
What page is that?
Say again?
What page is that?
What page is which one?
The number
Oh, sorry. Page 411. Section 8.3. Okay. So again, real quick recap. What the hell are you talking about? What can you use to talk about it? What's good enough evidence? Right? So C and D is where I actually do the work. What's good enough evidence to show something? And then step D is, did you show enough evidence? Right? That's where you look at your sample and you see what happened. Did I get this far away from what they think it is? Right? If I get a sample that the z-score is so big negative, it's so far below what they think it is, then it can't possibly be what they think it is. Right? At least within a certain level of significance. 1% chance we're wrong here. So step D now is poor little dude, come on. What do I do in step D? You guys all right? Did you have turkey this morning? You know it has something in it, tryptophan? Yeah, bad idea. Hopefully you didn't have turkey and wine this morning for breakfast.
The Z-star thing?
Very strange breakfast.
Z-star?
Z-star, cool. So this is where you get your sample info. You try to calculate your Z-star. And I might just call it Z-star even though we're using T-scores possibly in a problem. Who cares? I really want you to understand. It's the same stupid score. It's your sample score. You call it whatever you want to. I should just call it score star or something strange. Right? It doesn't matter what letter I use. It's just how far away my sample is. That's it. And then I can compare it to how far it needs to be. So what do I know for my sample? I know p hat. What do they tell me p hat is?
0.20.
Yeah, 0.20, 20%. I didn't have to calculate p hat. Be careful. Some problems will do that for you. And what's n? We already know n. 1501. That's it. P hat minus p over the square root of pq over n. Right? Careful now. Careful. Q hat would be 0.8. Which one do I want to use for the formula?
0.75.
P and Q. I never use sample info if I have the population info. And the thing about hypothesis tests is we're assuming, yeah, okay, let's say that's the population information. Let's just say it. And then we're trying to show, look what I just did. Look what I just did. No, look what I just did. It's something crazy assuming that's the population. So that can't be the population info. So we don't use the hatted dudes in here, right? It's a very simple mistake to make, I understand. And sometimes it actually will throw off your z-score enough to be in or out when it should be the other way around. So in here I'm going to put 0.75, 0.25, right? So it'll be my p hat, 20%. How far is that away from the supposed one? Square root of 0.25, 0.75 over n. Put this in here. Be careful again. You want parentheses around the top, and then open that parenthesis, close that parenthesis, or let that bar get big enough so it covers everything. Right? Be sure not to close that parenthesis too soon, and don't forget the parentheses on the top. The calculator is at a disadvantage. It sees things like this. So if you don't put parentheses on the top, what's it going to divide by?
0.25.
It's going to divide this when it really should be dividing this by this. That's why you need parentheses around the top. Okay. Still see that on some homeworks. People getting weird ass z-scores, and that's why. So what do you guys get as I?
Negative 1.47.
Negative 4.47? Okay. And I kind of expected this. You should be careful about making predictions here because a lot of times you really can't tell until the end. But it really did seem 20 is decently far away from 25. But I can't say anything at this point yet because I really don't know. It all depends on how big my sample was, all that kind of stuff, what the level of significance is, that kind of thing, right? But it did seem pretty far away, and sure enough, it bore out in the z-score. Let me see if I can do this real quick in here, in case anybody had trouble with that. 0.2 minus 0.25 divided by square root. Okay, cool. Yeah, negative 4.47. So where is that on my picture here?
It's farther.
It's way the hell out here. So we made it into the rejection region, which of course should mean we reject something. I mean, it only makes sense. So don't forget that little place you make here is the rejection region. If you get in there, reject it. If you don't, you fail to reject. Beautiful name for that place, right? So this, what's the little phrase I can write here now? Reject the low. Support the high. Notice how you don't accept anything. Supporting is not the same thing as saying somebody is right. I support that. It doesn't say you're totally right about that. Do you see what I'm saying? So it can never be definitive because we have all these uncertainties tied to this, right? It's a beautiful thing about statistics that people hate. They should really give it a break. So which one is my claim again? The H1. So I want to word my conclusion. Did I worry about the claim since I first wrote that word claim up there? Have I worried about it at all? No. Even here I didn't give a crap about it, right? Because I could write it based on the z-score I saw. So right here, I can write these statements, and now I worry about my claim. Okay, my claim was H1, so what wording do I want to use in my conclusion? Support the claim. Do you guys see how to figure that out? It's really nothing magical or hidden. It's right there. This is the claim. I want to use this wording. We have found. Because we didn't fail. We have found sufficient evidence to support the claim that what was going on? Less than 25% of that have a specific group. I can't remember now. Not really. Blah 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 blah. Oh, the population. I love it. Less than 25% of the population disbelieves global warming, right? Believes that there's not solid evidence. Blah blah. Yeah, disbelieves global warming. Just to cut to the quick. Yes, ma'am.
How would you find the p-value?
Okay, cool. This p-value, how do you always find the p-value? It's based on your z-score, right? So the tail that my z-score makes, in this case, what's weird about the z-score is it's off the chart, right? So you can either say one of two things. You can say what the chart says. What's the chart say? 0.0001, which I'll be okay with. So right here, if you say p-value 0.0001, that's fine. Even better is like 0 plus, or approximately 0, because it's even smaller than that. At 3.5 is 0.0001. Well, once you hit 4.5, it's smaller than that. It must have gotten a little smaller, right? So it's even smaller than that. Yes?
Will you show how to find it if it was a t-score?
Sure. If this was a t-score, See if I can get there quickly.
When would it be a T-score?
Which step in your, well, the big thing about this problem is it would never be a T-score for an NPQ problem. But just since we have the number there, we'll see if I can see about a T-score. And this one's going to be a little strange, to say the least, because of the fact that it's such a large sample. I don't know if you guys noticed, but you can all access this. I didn't have to log in or anything, right? So you can all access this website. Oh, where am I going? So look at the T chart. N is 1500, so I would use 1000, right? And alpha, well, what did we get for a z-score? A t-score, I guess, in that case? 4.47, and see how it's off this side? It's off to, let me see, up here would be better. 4.47 would be up here somewhere, right?
It's negative.
It's negative.
It's fine. This chart doesn't care about negatives or positives. It cares about distance, right? If you're 4.47 away, does it matter if you're up or down? No. Cool, because it's symmetric. Boogie woogie. So if you look up here, we said it was out here somewhere, right? So if you look up here, for a one-tailed test, P must be less than this. Do you see? Because it's even farther down than that. P must be less than this.
Okay.
Which it is. We know it is. So this chart is really easy to use because it's not very detailed, which means it's hard to use backwards. Because it's not as detailed as a z-score chart.
With 1500, would you use 1000 or would you round up to 2000?
I would use 1000.
What is it, 1800?
Yeah, and when you get to 1800, that's a gray area. You can go one or the other way. Because the larger the sample, the less important it really is, because the scores are really not changing that much at that level, right? Whereas if you're down here, they're changing a lot more than they are up here. Okay. Anything else about that problem?
So in rounding the degrees of freedom, like, what do you suggest? Like, what's a good rule of thumb?
I will understand. Well, on a test, I'm not going to give you a sample size that's exceptionally freaky. But if I did give you one that was like a sample size of 42, your degrees of freedom would be 41, but on this chart you would use 40. If I gave you a sample size of 45, degrees of freedom would be 44. I would take either one. Officially, you really should go down just to cover your ass a little more. But 44 is pretty damn close to 45, so if you use that one, I'd be fine. Do you understand?
If
And
43, we still use 45, right? Or 42, we still use 40, right? If we don't have it in there.
the official answer is you should always go down. But if it's so close and you go up, that's understandable. Especially if it's like, what if I give you a sample size of 187? The degrees of freedom would be 186. Do you want to go down to 100 or do you want to go up to 200? Well, at that stage, both ways is fine. Either way is fine. Yeah. Okay, maybe.
So always go down.
Yeah.
Pretty much, that's the rule. If your degrees of freedom is not on this chart, go to the next closest one down. Meaning,
Up the chart.
but it's still down from the number. Yeah.
I'm just confused in general why we use the T chart and when we use the Z chart.
Why can we use a T chart even if we need Z scores?
Because the
Z scores are down here. I love it. Cool. If this, now I really want to make sure you guys understand. This was a Z score. This is a Z score problem, right? Somebody had a question saying, if this would have been a T score problem, how would I find the p-value? That's the only reason I try to look that up on the T chart.
So like when do we use the degrees of freedom? What?
When you need a T score. So here's the shortcut. You ready?
I think she's saying, when do you need a T-score? She doesn't know.
I got you.
how.
Well, maybe. I didn't know. So why were T scores invented?
When you're not given a standard deviation.
Of the, which standard deviation? When you don't know the population standard deviation.
Okay.
So like on the quiz, the take-home quiz, hopefully you guys use T-scores because you calculated your S, right?
See,
Now, I did have a few people email me and say, can I just calculate the standard deviation of all the 182? I'm like, good God, if you really want to. But I try to be very specific, saying use your sample data. So I was really trying to push you in the direction you have to use a t-score then, because you only have S, you don't have sigma, right? Okay, is that cool?
Yeah.
Ruh-roh, okay. Oh, okay. Yeah, anybody else still have their take-home quiz? Give me. All right. Oh, okay. So, any other questions from this hypothesis test? Any other quick questions that don't involve doing an entire hypothesis test from chapter 8? So obviously, I mean, a big complaint about math and math teachers is we assign these crazy long problems. I'm obviously not going to assign 8 hypothesis tests on the test. I mean, come on. That's crazy. They do take a little bit of time, right? But to tell you honestly, there really isn't too much on this test. There's confidence intervals, hypothesis tests, and then what we're going to do today. To tell you honestly, though, hypothesis tests and what we're going to do today do take a little bit of time. So this test is not going to have a lot of problems on it, but some problems are going to take a while to do. Okay? Yeah?
I'm an easy one, number 4 and 8 4.
Bless you. Oh, if you found out that by, let me see, how should I say it? If you slept 16 hours a day, if they did a study and said people who sleep 16 hours a day they add 2 days onto the length of their life, that could be statistically significant. Now let me explain that real quick. That means that what they did, the test they did, shows a statistically significant difference between those people who sleep 16 hours a day and those who don't. So it would be like a z-score in the rejection region. You guys with me? It's so different that there is a difference. There is a difference. Is that difference practically significant? Would you immediately go, man, I want 3 more days on at the end of my life. I'm going to find a way to sleep 16 hours a day. Is it practically significant? No. So you could have a statistically significant difference. If you live on the moon, then you will grow an inch taller, right? And that's statistically significant. They say, yes, we have somebody who's been living on the moon. We forgot somebody in one of the little moon missions, and he's been living up there, and suddenly he's an inch taller. There's, whatever. But is it practically significant? No, I'm not going to move to the freaking moon just get an inch taller. I can just put inserts in my shoes or something, right? You guys, do you understand the difference between statistically significant, just meaning this? Mathematically, is it far enough away? Does it meet this criteria? Yes or no? Okay, we can do the test. Is it then practically significant? In that specific problem, it says you could lose weight. What did it say? The zone diet, weight loss of 2.1 pounds.
In a year.
Yeah, in a year. Right? Is that true?
No.
That's crazy. It had statistical significance, but not practical significance. 2 pounds in a year is not enough to make me go, yes, I'm going to do that diet. I just got to lose those last 2 pounds. No, that's not. I'm not going to do that. Does that make sense? Yes.
Okay, I have one more quick question on 7.4. Will you just talk about number 2?
7.4. My favorite one. All right. So, and again, I did talk about last time, but being robust against departures from normality means that because of the fact that part of the process is taking a sample, and to use the central limit theorem, you have to have a sample that's larger than 30. Does it care then that the original population is not normal? No, because it's robust. It says, no, if you take samples of at least 30, then it will come out approximately normal enough. So that's what they mean by it's robust against departures from normality. Is it robust against crappy-ass sampling techniques? No. If you only talk to your friends and you got 2,000 friends on Facebook and you get a little survey and do all this awesome stats on it, I don't care, right? It's not good. It's not robust against that. Nothing is robust against bad sampling. If you have bad data, there ain't a damn thing you can do about it after the fact. Okay. So, now we're going to get into chapter 10. And in your homework, in the book, they split this up into 2 different sections, but here's the nice thing. This is the one chapter that I agree with doing it all in the calculator, all the math in the calculator, because we have a lot of interpretation to do after we do that, right? So the nice thing is what I'm going to show you today is how to plot the data and get a nice little plot of data, and then how to also lay on top of that something called a best fit line, right, which you guys have probably seen somewhere in the past, but you might not know what the hell that really means. Let's see, do I have any more of those handouts? Yes. So if you guys have your little handout, and this is actually when I got the job here, I had to videotape a class, and I videotaped my stats class, and we happened to be talking about this. Come to find out, some of my colleagues just enjoy the fact that I discussed beer in a math problem, so there you go. So for the first problem, I like this problem because it's very real life. You can imagine this. If you go out drinking the night before a very early exam the next day, and you actually go in and take the test, do you think that there would be some kind of an effect because of that? Yes. Now, will everybody be affected the same way? No. So which one of these pictures, do you guys understand these graphs here? That was neat. Oh, let's see. All right, cool. All right, so which one of these pictures is more realistic? So you see how the grades, as you drink more beers, the grades go down in both cases, right? The guy who drank more beers here got a very low grade. In reality, what's going to happen? Some people, I don't care how sober they are they going to do well on the test? No. Some people, I don't care how many drinks they drank. Some people are lucky. They don't get hangovers. They can hold their liquor well, right? So they're going to be fine, especially if they already know the stuff. So you got this guy. Who's this guy? Didn't drink very much, but didn't get a very high grade, right? And then who's this guy? Drank a lot and still got a pretty good grade, right? Yeah. But overall, what's the trend either way?
The more you drink, the lower.
Yeah, the trend is a downward trend. The more you drink, it seems the lower your grade's going to be. Okay, how are we doing so far? So obviously, a huge part of statistics is examining how things affect each other, right? Psychology is really big on this. And unfortunately, I always have the same example come to mind about what age you're toilet trained and how you act later in life, or if you played with fire when you were a little kid and what happens to you later in life, those kind of studies. You always hear something about, well, William, he was a little boy, he was a quiet little boy. And then he kills all these people when he was old. Or they're always trying to find correlations where they shouldn't, like the Columbine shootings. And now they're trying to profile students to know ahead of time when they're going to do something. And these are just normal freaking teenagers who are lashing out against all this crap, and they're trying to say, well, oh, there were signs. No, there weren't. You don't have a clue, right? Sometimes there are signs, but sometimes they are not signs. They are just kids being kids. So that kind of thing, I don't want to be involved in that because it's impossible to really get that. There's no correlation there that's really strong enough. Which one would you say is a stronger correlation? Talking about that. Yeah, so inherently, it kind of makes sense. This is a stronger correlation. The number that we're eventually going to calculate that measures how strong this fit is should be more here than it is there. right? And thankfully that number, the closer it is to 0, the less correlation there is. And the closer it is to 1 or -1, the more correlation there is. And really, what does correlation really mean? Did you guys see how here I can draw a line that sort of averages out where the points are? And here I can do the same thing. And of course, the one that's tighter is the one where the points are, or the one that's stronger is the one where the points are tighter to the line. Okay, cool. So if I can predict then, well, if I had one more beer, if this was reality, if I had one more beer, what would my grade be? There. Right? I could then use that line to see what, if I had no beers, my grade would be there. We can then make predictions based on that line that we find. How are we doing so far? So what the book does in 10.2, they focus on the strength of the correlation. In 10.3, they focus on the line that represents the correlation. Okay, maybe. So for example, and I didn't bring it with me, but for each of my classes, I often do a correlation between the number of homeworks that were actually turned in versus the current overall grade, not including homework. Real quick, why wouldn't I want to include homework in the grade if I'm trying to find a correlation between homework done and grade?
The overall grade would be dependent on
Exactly. I would mathematically make it dependent, so my correlation would be higher than it really should be. So I look at how much homework have you turned in versus your current grade, and I always get decently strong, statistically significantly strong correlations between it. And thankfully in the positive direction, meaning the more homework somebody's turned in. I even look to see if they've done it well. Just have they turned it in. And there's always a strong correlation. Always a strong correlation. And just to go back though, does that mean that doing more homework will increase your grade? No. Correlation does not imply causality. I don't know what factor really causes the other one. And normally it's the type of student. They're going to do well no matter what they do. And normally that type of student does the homework. Okay, here's one more example. A little more boring. The number of hours studying the grade you make on a test. Would you say that that's a positive or a negative correlation? Obviously positive because the slope is positive. So this would be a negative correlation. The more beers I have, the lower my grade gets. So it's inverse. One goes up, the other one goes down. And here, which one seems more realistic? Yeah, this one's getting more realistic because here's the guy that studied his ass off and still made a really bad grade. And here's that person that never comes to class and never studies and they still make A's on the test. Right? Yes. Okay. Blah, 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 blah. So what we're going to do now is we're going to focus on the math. We're going to focus on finding this thing called R, which I'm going to call the correlation coefficient, but very often you see it called the Pearson product. I'm going to call it the correlation coefficient. That makes more sense. It's how strong the correlation really is. Then we're going to focus on, before I get too far, -1 correlation would mean perfect negative correlation, meaning something like this. What would it mean to have perfect negative correlation? What should the points of the data do?
form a straight line.
Form a straight line. And in order to be perfect negative, they have to be
Down increasing.
I love it. So you have like this. So that means all the data points actually lie on the line of best fit. This would be R equal to -1. Perfect negative correlation. So what would perfect positive correlation look like?
One just be exact lines. Be a line going straight
So
up.
just be the other way, yeah. Now, to be careful, these lines have to be, oh crap. Should be straight, but oh. Here's an example. What would you say is true about this here? But it forms a straight line, right? So are these correlated? So this could be how high I can jump, and how tall that tree over there is. All right, so I jump a little bit, and then I measure the tree. I jump a little bit more, and then I measure the tree, right? You see what I'm saying?
Yeah.
Or it could be that guy from the basketball problem, remember a million years ago? Play some basketball, measure the dude. Let him play some more basketball, measure the dude, right? I don't care how much freaking basketball you play or how much I jump up and down, the height of the tree or the height of the person is not going to care. So you got to be really careful. This does make a straight line, but this is a very obvious, do the variables care about each other? No. Right? This guy's like, I don't care how much you jump. I'm still the same freaking height that I am. Right? You guys with me? So this is would still be r equal to 0. What about this one? Well, we've seen something like this before. The giveaway is it keeps saying line of best fit, line of best fit. This has a fit. This has a correlation. Let me throw a word at you that might freak some of you guys out. It's got a quadratic correlation. This definitely has the shape of a parabola, which has like an equation like x squared, blah, blah, blah. Right? That's quadratic. So we're not going to focus on quadratic. We're only going to do linear. So this has no linear correlation. The best line I could draw would be that one. And that's a flat line. That's no good. You guys kind of with me? So for those of you at all interested in this, beyond what I'm going to talk about, there are tons of other correlations. There are cubic correlations, linear correlations, logarithmic correlations, power correlations, all this other stuff. Right? So for example, I told you about the homework versus the grade. The best fit wasn't a line. It was actually this interesting power. It had a little curvature to it. And it fit really well. I was like, oh, that's kind of cool. Doesn't really mean much. Not really. Okay. So let's get into the nuts and bolts. Yeah.
Real quick, back to this. I'm confused. On the first set of graphs, you said the stronger graph was number 2, but on the second set, you said the stronger graph was on the right too. So I'm all confused.
No, this is definitely a stronger one. Did I say it was this one?
It's more realistic.
More realistic,
More
yeah.
realistic.
Yeah, this is real, stronger. Yeah.
Okay.
Now, I'm not trying to say that in real life there is nothing that's really close to lined up. Right? For example, if you take fish and you sample fish from a nice little lake at different ages, their lengths are going to be lined up pretty well, right? Now, if you take fish from a lake and you take fish from some other place that might have pollutants in it, then you might get some weird thing going on, right? But if you have a nice population, something like height, it's got a beautiful normal distribution, right? It's going to line up pretty well. Age versus length is going to line up pretty well. It's going to be correlated really well. You guys with me? Roughly? Okay. So let's look at the actual nuts and bolts. No, leave Google Toolbar off. Okay. I think on the back of this sheet I have some data, right? Let's try some of this out. I think, unfortunately, good. It's not terribly long. And I put this is actually on your calculator Bible, but I just put this here again in case the calculator Bible has gotten lost somewhere along the way. So here's my attempt at mimicking the graph on the front, making some data points that actually kind of create that image we have up here. I can't remember which one. I think it was this one. So what we're going to do now is just the procedures for how to do this kind of problem. How would you get a problem like this? They would give you the data, and they'd say calculate the correlation coefficient.
Do you have extra calculator?
Yes, up here. Maybe. Yes. There's plenty up here if anybody needs it. All right, so here we go. Here's how you do this. Go to Stat, Edit, and just put in your data. By the way, how many variables are we working with now? 2. Be careful, not how many data points, how many variables, number of years, and grades. We have 2 variables, right? So here we go. How did I get 15? That's good, Jeff. Bless you. Oh, I only won 4. There you go. What do you think about sorting this data? Should you? Well, it's not that it doesn't matter, it's that you should never ever do it. Because the beers, 4 beers must go with 82, right? If you sort them, they're not going to necessarily stay together, are they? And then you everything will then be correlated. Right? I've just found a correlation. I don't know if you guys, there was on one of the things I don't think I handed out, but it's I found a correlation between the number of cats you own and the probability lightning will strike your house. Well, I don't know about that, but you get weird correlations, of course, when you do that. Okay, so I think everybody's got this data, so I can switch over to the calculator here. So I got the data put in there, right? If you wanted to, in fact, just to blow your mind for a second, if you look on page 498, halfway down the page, you're never going to have to look at this again.
I'm gonna sort it out, right?
Don't sort it, yeah. Please don't. Dear God. Like I just said, the data points have to stay together, right? Here is one reason, and this is not really the only reason, I want you to understand. One reason why I don't worry about doing the formula is because there's the formula. There's the R. Now, if you had to, if I did, can you see how to do this? It says sum of x, y. So you want to get your x's, your beers, your grades, and then you want to have a column that would be x times y, beers times grades. And then you add them up. So you could figure out how to throw all this stuff in there. I only really want to use these if you can see the concept easily in the formula. The concept is lost in this formula, right? It's really not easy to see where the concept is. Some of you guys might realize this is the top of the standard deviation for x's. So it should make sense that standard deviations should show up in this because there is how far away the points are from the line. And I always think of that as like a two-dimensional standard deviation. How spread out are they? The line is like the average, and the more spread out they are, that's going to change my R value, my like two-dimensional standard deviation. You guys no, not at all. I try. R should be 1 if they're all right on the line. The minute I pull some of those points away, that means they're varying more away from the average, which is really what standard deviation measures, right? It measures how much they change from the average. So that's why that idea should show up somewhere in the formula, and it does. So coming back to, so that's the last time you have to look at that formula. We've got our data in there. Here's how you calculate, and actually we're going to see everything show up. We're going to see the line of best fit, and we're going to hopefully see the R. If you don't have R show up, I'll show you how to get it to show up, so don't worry. And the very first, before we even do that, up here above y equals, see where it says stat plot right there? So everybody do that, hit second, y equals to get into stat plot. I can't remember if I did this earlier with this scatter plot we had to do, but this will make scatter plots for us. Make sure, first off, make sure that they're all off to begin with. Maybe one can be on because we're going to go into one and turn it on anyway. But if anybody else is on, just hit, second, y equals. Hit number 4, enter. So that all the plots are turned off. We don't have anything else coming in being freaky. Good, here we go. Second, y equals. That gets you to here. Number 4 is plots off. Hit 4, enter. It'll turn all the plots off, right? So you don't have any other plot trying to take over. Now go back to second, y equals, and let's hit enter to get into the first one, the plot 1.
I still have plot 5 on. Yeah.
No, 5 is to turn all the plots on. It's okay. You only have 3 plots. 1, 2, 3. 4 turns them all off. 5 turns them all on.
Do you always have to click number 4? Do you always
Not
have to
anymore
turn it
now.
off?
Yeah.
Oh, like
If that's your calculator you've got, if you have your calculator, what we do today is going to get it set up for the test, really, which is nice. Right? You're not going to have to do some of what we're going to have to do right now. So let's turn this first one on. Is everybody with me? So second, y equals, hit enter to get into plot 1. Turn that bad boy on. make sure that the type that's highlighted is here. So to change it, you just go on top of somebody and hit enter. So if I wanted that one, I could hit enter. But what we want is the first one. We want a scatter plot. And it's been a little while, but I don't know if you guys remember in that one homework set we had earlier, we had to make a scatter plot. It was like energy versus temperature. Right? So what we're going to do now is we're going to let the calculator do the scatter plot. It is a graphing calculator. It costs a lot of money. Should be able to do it. You should have, of course, my x variables are in list 1. My y variables are in list 2. Right? Is everybody cool so far?
Yeah.
Please, dear God, let me know if something weird's happening. Yes?
I have this equipment over here.
Oh, so turn it on. There you go. Cool. Now you're good. List 1, list 2, I like it. Everything's good. Cool. All right. And then you get to pick which symbol you want to be. Obviously, I am a square. I am a math teacher, so that's a given. Are you positive today? Are you a speck of dust in the universe today? So you get to. That's just going to be what they're going to put on your data points, right? So I'll be a square. You guys can be whatever the hell you want to be. Now, if you hit graph right now,
You're not going to see anything.
you're not going to see a damn thing, right?
Zoom box. Or zoom stat.
That's the one. There's a built-in function in the calculator where it finds your data. Because where is my data right now? My data, for example, one point is 0.598, right? Half a beer got a 98 on the test. I can't see that, right? This goes up to 10. So the nice thing is, whenever you put new data in, you always hit zoom, and it's number 9. At least for me it is. I think it might be different on some of the newer ones. Zoom stat. Kind of makes sense. Zoom in on my statistics. So we do it again. Zoom's right here in the middle. Basically, all the buttons at the very top of the calculator are graphing buttons. Right? Zoom, and then number 9 is zoom stat. And if you do that, you should get this. So it was the first one, yeah. If you look at it, I tried to mimic that, and it did come out pretty well. How are we doing so far? Are we all right? Error? Oh, good. Okay. So, not good that you got an error somewhere. Anybody else get an error? What's your error say? Okay. And in fact, on your calculator Bible, I addressed the most common errors. There are 2 errors that happen. Syntax error normally means you have something really weird in your y equals. So hit y equals and see if they're all clear or not. Because this is where some of you guys might have not really used this graphing calculator before this class. If you got into Grossmont, you probably should have if you took 110. But this is how you would graph like 8x minus 9. You put it in there, right? But what happens sometimes, for some reason, I've seen this happen, there's just random symbols in there. So if I go to zoom 9, is it what? Now the nice thing is, does yours have a go to? Go to, and it takes you here and it says, this is where I'm having trouble. And you go, okay, let me take it away. Delete or clear. Now, hopefully, I'm hoping that's what's going on. Did your y equals have stuff in it? Oh, yeah. Just delete those out. Clear, clear, clear. Yeah. Oh.
So clear those out.
Yeah, anything you have in y equals, just clear them out. Delete them or clear them. You guys doing all right? You're good?
It's not. It does this though. It's different. Let me teach you. Do you figure it?
What's up?
You can't get it.
How do you get to that one? That's what I'm trying to figure out. Go to zoom.
Zoom stat. There you go.
Oh, okay. You're fine. All right. Yeah. It was just zoom.
All right. Now, anybody else get a different error? Oh yeah.
Clear it.
Oh, your stat. Now it's highlighted on that.
All right, cool. So second, zoom.
Oh,
9.
and that's list 2 and see list 1, list 3. So if you go to stat, set up editor, go back in on list 2 is back. Here's what I'll do.
Oh, your stat class not on.
Clear out list 2, and then I'll tell us put everything in list 3. I'll put it in list 2. So we'll just copy it over. Because everything, see how it's built on list 2. So now that it's zoomed, everybody all right? The other possible error you can get is dim mismatch. And that's dimension mismatch. Like your two lists are not the same size. And of course it's going to freak out. It's like me saying, plot the point, empty space, comma 7. And you're like, wait, I don't have an X piece. So that's where the calculator go, what the hell's going on? That's the other possible error you can get. Okay, so now we've got this graph. We can tell that it should be, let me use this wording, kind of a weak negative correlation. You guys agree with me? It's not very tight. I can't see a beautiful line up there, but it does have a downward slope to it, but not very strong. So I'd expect R to be closer to what? 0 on the negative side, right? So and it actually is a little bit stronger. So maybe like negative 0.3, negative 0.4, something like that. Because I can't remember now what this comes out to be. So we'll see what it is. How do you guys feel about what I just said? Does that make sense? R equals 0 means no correlation. The stronger the correlation, the closer it gets to 1 or negative 1. That's not very strong. So it should be somewhere in the middle maybe. So let's see what it is. Go to stat. Where do you think I go now to get my R? Calc makes sense. And then which one of these looks like it has to do with lines of best fit? Yeah, I love it. Real quick, I have no idea why they included this. See how it's A plus BX? And number 4 is AX plus B? That's always been kind of funny to me because why the hell, what? And so how does this relate to algebra? Yeah, A is the slope here. M was the slope in algebra, right? So hit number 4. You should have that show up, right? Linear regression. It defaults to list 1, list 2. So you can just hit enter right now. Just like one var stats defaults to list 1. If you put your data in some other list, then you have to tell it which lists. I put mine in L1, L2. I can just hit enter. How we doing?
What if I only get one line of thoughts out?
Oh, no, you're fine. I did it twice just to kind of show it. Don't worry about the other stuff on the screen. Don't worry about the man behind the curtain. No, don't worry about this stuff. Linear regression. Hit enter. Let's see what comes up. Now, some of you guys are going to get more than I got, which is beautiful, which I'm hoping.
I don't have to do anything for these two. Just
Oh, yeah, you can just do it directly. Okay, cool. Try it. See what it does. Now, real quick, did everybody get at least this?
Yes.
Anybody get more than that? Because I am missing a crucial piece right now. I'm missing the R. Anybody else missing the R? Anybody else like me? I'm kind of happy that this didn't have it, so you didn't feel like you didn't want to raise your hand. I don't want to tell them. It's normal. If you have your own calculator, what I'm about to do with you will set it. You'll be ready for the test, right? If you're borrowing one, I can't say. I don't know. So you can always just bring it up to me and I can set it for you before the test. So here's what you do. You only have to do this once. Hit second 0. This is the catalog of every damn thing the calculator can do. Don't ask me why, what's going on. I don't care. Just do this. See this button here? X to the negative 1. See how there's a little D above it in green? So I want to hit that so I can get to the D section. D for Dan. That's right. Don't have the alpha, just have the button. Because it kind of comes in knowing that you might want to go to a part of the list, so it's set for alphabetical, right? So everybody got to this part now? That needs to? So now you scroll down to what says diagnostic on. There I am at diagnostic on, right? My little arrow. Hit enter, enter. Little anticlimactic. How we doing? Then you go back to stat, calc, number 4, and now R should show up. So again, I'll do it again. Stat, calc, number 4 for the line of best fit. Sweet. How are we doing? So a couple things. R came out to be negative 0.3. Hey, sweet. We knew it was a slight negative tilt, but not very strong, right? It's closer to 0. Cool. What else can I see here? The line that would best fit this data has a slope of negative 2.5, blah, 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 and a y-intercept of 89, blah, 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 blah. So here's the final cool thing. Yes, ma'am?
I don't see R squared in R.
Oh, so that was that thing here. Oh, here's the diagnostic. Oh, you had to enter after this to turn the dialysis on, and then hit by itself. Cool. All right, everybody else cool with R? So here's the beautiful thing, and this is actually what I'm going to need on this test and the final. You must come up to me at my desk and show me on your calculator this to get credit for this part of the problem.
This right here?
No, I'll show you. This, like with dot, dot, dot.
Oh, okay.
Go to y equals, somebody, actually, let me write this equation down so I don't forget. What is it, negative 2.535 plus 89.83, yeah, that'll do it. So go to y equals, and put that in. Oh, what's up?
I just didn't get past this part.
Oh. Gotcha. Because you had to hit second, and then this. There you go. Cool. Sorry. So here's your negative button. Be careful, right? The negative button's at the very bottom. This is your minus. Don't use your minus button. So negative 2.535. Don't forget your variable. If you just do this plus 89, that's just a number. It's just going to be a flat line, right? Y equals 7. It's just a flat line. So I have to put X. Here's my X button. See that? There's my X button right there. Bam. Negative 2.535X plus 89.83.
There's a X. I don't see X.
Up next to your alpha button. Cool. It's got a lot of other little variables on them too, but how are we doing? Now if you hit graph, it throws the line of best fit in there.
Oh, that's cool.
That is freaking cool.
Oh, God. So that's we have this showing on the test?
Yes. So, one quick little thing, and then I want you guys to actually try the second problem on the back by yourself before we leave today. I do want to show you one thing. On the test, do not worry, I'm not going to make you look this up yourself, but you should probably be curious about how strong does R have to be to actually show correlation, right? And maybe somebody realizes it should depend on how large your sample is. So for this case, I think our sample was 14 big, right? Sample was 14. I'm going to give you this number on the test, so don't worry. I'm not going to make this a big thing, but let's use the alpha 0.05. For N14, this is how big our R has to be to show correlation. And just like the T-chart, this is not going to have negatives on it, right? So did we get far enough away from 0 to show correlation? We only got to 0.3, right? So we've just kind of proven, we've shown evidence that there is no correlation then between the number of beers you drink and the grade you get, right? There wasn't strong enough evidence for that.
So you can't trust a prediction.
I can't trust the prediction with that line. I love it. So the closer, the better R is, the farther R is above this number. So if I would have gotten an R of 0.7, I would have trusted the line to make a best fit, but R of 0.8, I would have trusted it even more. It would have been even better to make predictions about